Welcome to our channel where we explore the fascinating world of technology and its impact on our lives. Today we're diving deep into a crucial aspect of modern software development, machine learning engineering for MLOps. We're thrilled to have you join us on this journey of discovery. Before we begin, we invite our friends and viewers to share their thoughts, comments, and suggestions for future videos in the comments section below. Your engagement helps us create content that resonates with you, so don't forget to like and subscribe to stay updated on our latest videos. Now let's embark on our exploration of machine learning engineering for MLOps. To understand machine learning engineering for MLOps, we first need to break down these terms and concepts. Let's start with the basics and build up to the more complex ideas. What is machine learning? Machine learning is a subset of artificial intelligence that focuses on creating systems that can learn and improve from experience without being explicitly programmed. It's like teaching a computer to recognize patterns and make decisions based on data, much like how humans learn from experience. Imagine you're teaching a child to identify different types of fruits. You repeatedly show them apples, oranges, and bananas, explaining their characteristics. Over time, the child learns to recognize these fruits on their own. Machine learning works similarly, but with computers and vast amounts of data. Now that we understand machine learning, let's move on to engineering. What is engineering in the context of machine learning? Engineering, in general, is the application of scientific and mathematical principles to design, develop, and create products or systems. When we talk about machine learning engineering, we're referring to taking machine learning models and algorithms and turning them into practical, scalable, and efficient systems that can be used in real-world applications. A machine learning engineer is like an architect who designs and builds a house. They take the theoretical concepts of machine learning and construct robust systems that can handle large amounts of data, process it efficiently, and deliver reliable results. Now that we've covered machine learning and engineering, let's introduce the concept of MLOps. What is MLOps? MLOps, short for machine learning operations, is a set of practices that aims to deploy and maintain machine learning models in production reliably and efficiently. It's an extension of DevOps principles explicitly applied to machine learning systems. To understand MLOps better, let's break down DevOps first. DevOps is a set of practices that combines software development, dev, and IT operations, ops. It aims to shorten the system's development lifecycle and provide continuous delivery with high software quality. MLOps takes these principles and adapts them to the unique challenges of machine learning systems. Why is MLOps necessary? Traditional software development practices often fall short regarding machine learning projects. This is because machine learning systems have unique characteristics. Data dependency. ML models rely heavily on data, which can change over time. Experimentation. Developing ML models requires extensive experimentation with different algorithms and hyperparameters. Reproducibility. Ensuring that ML experiments and results can be replicated is crucial but challenging. Model decay. ML models can become less accurate over time as the real-world data changes. Complexity. ML systems often involve complex data processing pipelines, model training, and deployment. MLOps addresses these challenges by providing a framework for managing the entire lifecycle of ML systems, from development to deployment and maintenance. Now that we've covered the foundational concepts, let's dive into machine learning engineering for MLOps. Machine learning engineering for MLOps is applying engineering principles to the design, development, and maintenance of machine learning systems within an MLOps framework. It involves a wide range of skills and responsibilities, including data engineering for MLOps. Data is the foundation of any machine learning system. In an MLOps context, data engineering involves preparing data for model training and setting up robust data pipelines that can handle streaming data, detect data quality issues, and automatically update datasets as new information becomes available. For example, imagine you're building a recommendation system for an e-commerce platform. As a machine learning engineer, you'd need to design a system that continuously ingests new user interaction data, processes it in real time, and makes it available for model training and inference. This requires setting up data storage systems, ETL, extract, transform, load, pipelines, and data validation checks to ensure data quality and consistency. Model development and training. Model development goes beyond implementing algorithms in an MLOps framework. It involves creating modular, reusable code that can be easily integrated into automated pipelines. This might include 1. Implementing feature engineering pipelines that can be applied consistently across training and inference. 2. Designing flexible model architectures that can be easily updated or swapped out. 3. Implementing efficient data loading and pre-processing routines to handle large data sets. 4. Set up experiment tracking systems to log each training run's hyperparameters, metrics, and artifacts. For instance, you might use tools like MLOps to track experiments, Optuna for hyperparameter optimization, and DVC, data version control, to version your datasets and models. Model deployment and serving. Deploying machine learning models in an MLOps context involves more than just putting a model into production. It requires a robust serving infrastructure that can handle varying loads, provide low latency predictions, and seamlessly update models without service interruptions. This might involve 1. Containerizing models using Docker for consistent deployment across different environments. 2. Orchestration tools like Kubernetes are used to manage model serving infrastructure. 3. Implementing A/B testing frameworks to roll out new models safely. 4. Setting up API gateways to manage traffic to different model versions. For example, you might use TensorFlow serving to deploy your models, Kubernetes for orchestration, and Istio for traffic management and A/B testing, monitoring and maintenance. In MLOps, monitoring goes beyond tracking system health. It involves continuously evaluating model performance, detecting issues like concept or data drift, and automatically triggering retraining or alerts when necessary. This might include 1. Setting up dashboards to track key performance metrics for your models. 2. Implementing automated checks to detect changes in input data distribution. 3. Creating alerting systems to notify engineers when model performance degrades. 4. Designing automated retraining pipelines that kick in when certain conditions are met. For instance, you might use tools like Prometheus for metrics collection, Grafana for visualization, and custom logic to detect data drift and trigger model updates. Scalability and efficiency. As machine learning systems grow, it becomes crucial to ensure they can handle increasing loads efficiently. This involves horizontal scaling, adding more machines, and vertical scaling, optimizing available resources. Strategies might include 1. Implementing distributed training for large models using frameworks like Horovod. 2. Optimizing models for inference using techniques like quantization or pruning. 3. Leveraging cloud auto-scaling features to handle varying loads. 4. Implementing caching strategies to reduce redundant computations. Version control and reproducibility. In an MLOps framework, version control extends beyond just code. It includes versioning data, models, and entire ML pipelines. This ensures reproducibility and facilitates collaboration among team members. This might involve 1. Using Git for code version control. 2. Implementing data version control using tools like DVC. 3. Versioning ML pipelines using tools like Kubeflow pipelines or MLflow. 4. Creating comprehensive logging systems to track the lineage of each model from data to deployment. Continuous integration and continuous deployment. CI/CD. CI/CD in an MLOps context involves automating the entire process from model development to deployment. This includes automating tests, model training, evaluation, and deployment. A typical CI/CD pipeline for ML might include 1. Automated unit tests and integration tests for data processing and model code. 2. Automated model training and evaluation on new code commits. 3. Performance tests to ensure models meet latency and throughput requirements. 4. Automated deployment of models that pass all tests and meet performance criteria. Tools like Jenkins, GitLab CI, or GitHub Actions can be used to implement these pipelines. Infrastructure management. Managing infrastructure for ML systems often involves leveraging cloud services and containerization technologies. This includes 1. Setting up and managing cloud resources on AWS, Google Cloud or Azure platforms. 2. Using infrastructure as code, IAC tools like Terraform to manage cloud resources. 3. Implementing containerization using Docker and orchestration using Kubernetes. 4. Setting up distributed computing environments for large-scale data processing and model training. Security and compliance. Ensuring the security and compliance of ML systems is crucial, especially when dealing with sensitive data or in regulated industries. This involves 1. Implementing data encryption and access controls. 2. Ensuring model explainability and fairness to comply with regulations. 3. Implementing audit trails for all actions in the ML pipeline. 4. Ensuring compliance with data protection regulations like GDPR or CCPA. In conclusion, machine learning engineering for MLOps is a multifaceted discipline that combines software engineering, data science, and operations. It aims to create robust, scalable, and efficient machine learning systems reliably deployed and maintained in production environments. By applying MLOps principles, organizations can accelerate their AI initiatives, improve collaboration between teams, and ensure the reliable and ethical use of machine learning in real-world applications. As we wrap up this comprehensive overview of machine learning engineering for MLOps, we hope you've gained valuable insights into this exciting field. Remember, the world of ML and AI is constantly evolving, and staying updated is crucial to success in this domain. We encourage you to continue exploring these concepts and their practical applications. We'd love your thoughts, experiences, or questions about machine learning engineering and MLOps. Please share them in the comments section below. If you found this video helpful, don't forget to like and subscribe to our channel for more in-depth explorations of cutting-edge technology topics. Your support helps us create more content like this. Thank you for watching, and we look forward to seeing you in our next video.